Welcome all of you. Today we have to see RC Phase Shift Oscillator, its construction and working. Before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, this is circuit diagram of RC Phase Shift Oscillator. This is the transistor amplifier, and these are the RC ladder network or RC phase shift ladder network. See in detail the construction of RC phase shift ladder network. See, this is RC phase shift network. First figure shows single section of RC network. When sinusoidal voltage is applied to this circuit, means when we apply sinusoidal voltage to this circuit consisting of R and C in series. This C and this R, resistor and capacitor, are in series in this network. So the alternating voltage, this VI dash across R leads the applied voltage by an angle phi. Therefore, its value, that is value of phi, depends on R and C. This is a phase shift ladder network. The value of R and C is so selected that for a frequency f0, the phi is equals to 60 degree. Phi is equals to 60 degree. Then the figure 2 shows, this is the figure 2, shows the three sections of RC network. Each RC section produces a phase shift of 60 degree. This RC section produces 60 degree phase shift. This produces 60 degree phase shift, and this is also 60 degree phase shift. Thus the total phase shift of 180 degree is produced. So total phase shift by these three RC sections, that is RC ladder network, phase shift is produced 180 degree. Then see, this is our circuit diagram for phase shift oscillator. It consists, as we know, it consists transistor amplifier and RC phase shift network. The phase shift network consists three RC sections, R1 C1, R2 C2 and R3 C3. At particular frequency f0, phase shift in each RC section, we seen just that it is 60 degree. So the total phase shift produced by RC network is 180 degree, and the frequency which is f0. Then see working of this RC phase shift oscillator. When the circuit is switched on, it produces oscillations of frequency determined by the equation, which is F naught, which is equal to 1 upon 2 pi RC under root 6. And here R1 is equals to R2 is equals to R3, which is equals to R. And similarly C1 is equals to C2 is equals to C3, which is equals to C. Then the output E naught of the amplifier, here as we know this is PNP transistor, so output we get from the collector. So E naught is the output we get from the collector. So the output E naught of the amplifier is fed back to RC feedback network, which is fed back in this way to the feedback network, that is 3 sections of RC network, that is the feedback network. This network produces a phase shift of 180 degree. We just seen the procedure or the working of this phase shift network. Therefore, this phase shift network produces 180 degree phase shift and voltage EI appears at its output. So here voltage appears, which is applied to the transistor amplifier, which is applied to this transistor amplifier. Here it is applied, and then the phase shift of 180 degree is produced by this phase shift network, and also a phase shift of 180 degree is produced by this transistor amplifier. Therefore, total phase shift produced is 360 degree in the entire loop. So total phase shift is 360 degree. So total phase shift is 360 degree. So this 360 degree means what? It is a positive feedback. Therefore, our condition for the amplifier work as an oscillator which is satisfied, that is Barkhausen criteria is satisfied. That means in the Barkhausen criteria we must have an positive feedback for the oscillator. Therefore 360 degree phase shift means the positive feedback is achieved. So this is the phase shift oscillator. This is the construction in detail for your reference, and this is working. Then we see the frequency F naught, that is F output, which is equal to 1 upon 2 pi RC under root 6. And here R1 is equals to R2 is equals to R3, which is equals to R, and C, and C1 is equals to C2 is equals to C3 is equals to C. So this is the formula for frequency of RC phase shift oscillator, which is used in solving the examples on oscillator, on phase shift oscillator. So it is important formula for the examples or the problem solving. Then see advantages and disadvantages. So advantages are, it does not require transformers or inductors. It can be used to produce low frequencies, that is from few hertz to several hundred kilohertz. It provides good frequency stability. Then disadvantages are, gain of the transistor must be high to overcome losses in the RC network. The circuit gives small output. Frequency of oscillations cannot be easily varied. So these are the advantages and disadvantages of this phase shift oscillator. So today's lecture we seen that RC phase shift oscillator, its construction and working, disadvantages and advantages. So thank you.